so much for that. It's really great to be able to stand here and actually see you while I'm speaking to you instead of you hiding behind my slide set. So it's been a good long time, and it's nice to get out. It's good to get one done before they slam the door shut again. So I'm going to take I'm going to take you on a little bit of a journey over the next 20 minutes. But I like to approach it from the why first instead of the what. The slide production is largely about the what and the how. But the why is kind of in your pouch there a little bit, in the green facts and in the CN30. These have come to be in existence for the simple reason that we need a lot of food, and there's an environmental impact of actually doing that. But we can manage that if we take the right and innovative approaches in order to get there. So that's where this long mouthful of a word comes in that I'll get to a few slides down the track. But yeah, this is me. I'm now FutureFeed Chief Scientist. I used to be CSIRO Senior Scientist, and for a period of time I was both. But the time has come to fully focus on this subject, so all my other CSIRO work has been taken over by some very worthy individuals who will hopefully bring those to you before too long. Now, I'm going to show you something that is, in essence, a little bit shocking, but I think it's something you've all seen before in some format. You've seen all of these, but you may not have seen them all in one place before. So this is what the carbon concentration in the atmosphere looks like now, which is up about here. But this is what happened around 1950. Well, between early 1900 and 1950, it stopped being a slow rise to a rocket to the stars. And this is what the methane in the atmosphere looks like. Around about the same time, it makes this almost vertical climb over a very short period of time. This one's a little spooky. What you're looking at here is species extinctions. Around about the same time, about 1950, rocket to the sky. What do you think the next one is? Any guesses? How about population? Around about the same time, rocket. You think there's any connection? If there isn't, the coincidence here is remarkable. Nonetheless, the atmospheric accumulation of greenhouse gases has reached a point where it doesn't matter if it's a cycle or not. Like there's a guy, Frank Mitloehner, if you know of that name. He has a great talk about how livestock cycle carbon in the atmosphere. So grass grows by sequestering carbon, the cows eat it, some of it goes back in the form of methane, some is CO2, some of it is consumed and then decays later back into CO2. It's just a cycle. That's true, but it's a relatively long cycle. And if you don't think 10 years is a long time, take a look at these graphs again and see what happens over a period of 10, 15, 20 years. So that means if we can roll back emissions from cattle, if they're not part of the major accumulation because it's a cycle, they can now become negative emitters, which means if we stop methane emissions from livestock, they're now consuming more atmospheric carbon than returning. So the cycle has been interrupted in a beneficial way. If we look at it in terms of what they are, in terms of emitters per emission, just forget the cycle part for a moment. This is a Bill Gates slide. If cattle was a country, the Republic of Cattle, they would be third in terms of emitters globally. Some argue that it's that it's more than that it's closer to China. I don't have all the specs on that, but this makes good sense when you think about what we really need to do. So that's the why. Some of the options, some of the hows that we have out there, they're all important. They all have a role to play. And they all are relatively easy to get into play at some level. So Desmanthus, as a legume, is Agrimix, is a company that's working towards commercializing this and making it available. It does have an impact in grazing systems, as does Lucana. You do get some productivity benefits from it, particularly at certain times of the year, particularly. But that's a relatively low number, as you'll find out in a minute, but still very important. And you think of it in terms of numbers of animals that you can reach with something like this. Any kind of a feed ingredient or additive to grazing systems is difficult. So this comes into play with a large number of rangeland that you could potentially reach with that. The 3-knob, or now known as Bovaer, a DSM product, has a pretty good reduction in about the same realm as these, maybe a little bit more as a feed additive. But as a feed additive, at this point, you're pinned to feedlots with formulated feeds, or potentially in a pulse feeding system like dairy cattle or other animals getting some form of a supplement. But it's inconsistent. Pulse feeding is inconsistent. Some animals get more than others. Some don't touch it. Some touch it a lot. So how that's going to work is yet to be sorted out. We're working on that, and we have a roadmap to get into that market. But the first thing we want to do is get those low-hanging fruits as quickly as possible. That's formulated feeds and supplemented animals that we can get to quickly while we work in the background towards getting into these types of systems. Even a little bit can make this 20 to 25 up to 35, 40 when you start combining these things. So that's worth thinking about. So in this journey, I met with a man in Prince Edward Island, Nova Scotia, or Prince Edward Island, right next to Nova Scotia, back in Canada. So Joe Dorgan, a very forward-thinking individual, quite a character in his own right, he noticed that the cattle that he was able to allow to access the seaweed that was near his paddocks were doing better. They got a little more milk, they were easier to handle, and he said they had rip-roaring heats. So he was very impressed by that, and he decided that he was going to sell his milk quotas, going to sell his farm, and go into the business of selling seaweed. So everyone could have that little bit of a benefit. So that's when he called on me at Dalhousie University. He said, I need to know if this is safe for animals before the Canadian Food Inspection Agency will allow me to sell it into the livestock feed commercialization. So I did some work for him. He didn't need to know anything about methane emissions for his purposes of being able to market his seaweed product. But because I could, I did. I took a look at the emissions from that, and we were getting about 20% emission reduction using his storm-tossed seaweed, which, by the way, they still collect in this way. So they still have the draft horses drag their cages along the tidal flats and pull out the seaweed, clean it up, and dry it up, and bag it. So he, from the work I did for him, he got a $300,000 grant from the Canadian government to get his business started. So that was a good start, but that was the light bulb for me. I said, there's got to be something out there with more punch than 20%, even though back in 2007, 20% was a big deal. And it was important, and what he's doing is important, and he gets a lot of other benefits as well. The one I forgot to mention was his dairy cows were pretty largely reduced in the amount of mastitis that they would get. So there was also a benefit towards immunoresponse. So cattle will go down for a treat if they can get access to it. So they will wander down. It's like I like to say about Australia, Nova Scotia the same way. All roads lead to either cattle or the ocean. Sometimes to both. So they will go down. This is actually in Connemara, Ireland. This is the Orkney Island sheep. Well, they eat nothing but seaweed until they go into lactation. Then they need a higher energy dense feed, so they'll go inland, and the producers there, the keepers of the sheep, will provide them with some hay and things, get a little more energy. This is in Norway. So clearly they will eat seaweed. So this is where this little seaweed came to be. I came to Australia to work with CSIRO and Meat and Livestock Australia and James Cook University because there were some other forward-thinking scientists that thought that seaweed might have something special to offer. So MLA had a program called the National Livestock Methane Program. And James Cook University and CSIRO were working together using the aquaculture scientists from JCU who were able to provide for us the chemistry of the different types of seaweeds, the reds, the browns, the greens, and the freshwater. They're not seaweeds, but they are macroalgae in the freshwaters. So we lined up all of these different kinds, took our most promising candidates, and made a cohort for an initial study. In that initial study, Asparagopsis showed up because I didn't believe what I was seeing. I couldn't find methane at all. It was completely gone. The low detection of our instruments to detect it in the head phase of these little bottle fermentations that we were doing. So there was a number of others that were also showing good promise, but we were looking at a relatively high dose in that first study, between 17 and 20% of dietary intake. Completely off the map in terms of being anything viable for the industry. So then we rolled it back. We took our top 7, 8 candidates, rolled the dose level back below 5%. 7 of the 8 lost their capability. They went, all methane returned. There was no benefit at 5%. Asparagopsis still below detection at 5%. Rolled it back to 2%, and then between 1 and 2%, you started seeing your dose response curve showing up. That's in a bottle. But of course, we moved from there quickly into a study with sheep using 1, 2, and 3%. The sheep refused to eat the seaweed. It was lying in the bottom of the bin. So we had taken the seaweed, sprinkled it on top of their lupin pellets, and they ate the pellets and left the seaweed on the bottom of the bin. But there was still 80% reduction in methane. What's going on? Well, I'm about to show you what happened. With the sheep, what had happened is they had eaten enough of that seaweed to get the effect. The effect in the animals was much greater than we saw in the lab, which is almost unheard of. Usually it's the other way around. In these little bottles, you get more of an impact than you do in the animal. So, at 0.2% of substrate in animals, this is in beef cattle, we got it down to 98%. I don't say 100% because we can't measure 100%. So I say 98%, but for all intents and purposes, we couldn't detect it. But a nice clean response curve was seen. Benefit of that is very little effect on dry matter intake. If anything, a slight increase. Average daily weight gain. A big benefit. at the high level. So we had to do it again. Of course, the Americans loved the idea. It was looking really good. So they wanted to do a study. So I worked with Hermes Cabral at UC Davis. And we did it a little differently this time. This time we went right through the transition period, from the starter, the transition periods, to the finisher diet. And here's what happened. This is what it looked like on the baseline. We hit the starter. We're getting really good reductions. Now keep in mind, as we go this way, forage content goes down and grain content goes up. As we got towards that finisher diet, we were down around 76 to 80%. This is the same inclusion level. So you can see that as the grain goes up, the grain content goes up, the effectiveness of the seaweed goes down, to the point where the two doses almost are the same. So the amount of forage in the diet has a big play in how effective it is. But we just need to tweak that in terms of how we feed them. So what we're looking at here is a generalized curve of all the studies up till early this year. You can see the basic response to the in reduction. That high point is the study we did in Townsville, and this is just increasing the amount of seaweed. But keep in mind, all these studies had different seaweed, which mean different quality of seaweed and different bioactive content quantities. So just to finish up for you, I'm just showing here a bit of how FutureFeed is going to do. I see Eve has changed it to a much smaller print, but still we're developing the viable products, we're testing it in vitro, we're going into small scale animal trials, and then demonstrating it in larger trials, and then we'll be moving towards demonstration in open paddocks. So this is our bit of a roadmap to getting into those grazing systems. It's complicated, that sounds simple, but getting it to them, getting it stabilized out in the paddock so that it's still an active product when they get to it is it's going to be a bit of a trick. So we got, right now we're using wild harvest and land-based cultivation using tanks. Ocean line farming is currently going on at pretty good scale now, but we don't have a product in the market right at the moment, but we're near to it. So my final statement is normally, listen, we can take this seaweed and we can give it to animals, but we've got a lot of benefit on the way there. So we can create new economies where, say, fisheries have collapsed, or in indigenous communities where there's water holdings. We can use that to scrub the water of all those nutrient runoffs and things like at the catchments, and consume CO2 while it's growing, and then fight ocean acidity, particularly around the reef, and then we reduce greenhouse gases. And if we can bring a little more of that productivity enhancement to light, then we'll have a benefit to the producer as well. So I'm just going to go past this because time is out. And this isn't really my forte around certification, but this is a big thing for us, to be trusted in the marketplace. So I think I can leave it there. Covered most of it, but this is basically where we need to go to get it live and get it moving at big scale.